So here we've got Claude code running in our terminal. You can see it's using Sonnet 4.6 with high effort mode enabled, which gives us the most powerful reasoning for our coding tasks. Over on the right, we've pulled up the Pi coding agent quick start docs, and we're about to install it using that npm command you can see there. npm install g ignores scripts ace irandil works pi coding agent. And down at the bottom of the terminal, you can see I'm already typing our first message to Claude, so let's kick things off and see what this setup can do. So we've just created our OpenRouter API key, and you can see it's displayed here in that modal, starting with SK or V1. Make sure you copy this now, because as it says right there, you will not be able to see it again. We're going to paste this into our terminal in just a second when we run that export OpenRouter API key command that Claude already laid out for us in step 3. So you can see Claude has automatically written our models.json config file with all 3 free OpenRouter models: Llama 3.3, Gemini 2.0 Flash, and Devstral. And it's even generated the exact export command with our API key already baked in. Over on the right, Pi is already running, but throwing a no models available warning, which makes sense because we haven't set that environment variable yet. Go ahead and copy that export command, paste it into your terminal, then run cd and p to relaunch it with the new config loaded. So you can see Pi has launched successfully, but it's throwing a warning that no models are available. That's because it can't find our config file yet. Over on the right, we've got our OpenRouter API keys dashboard open, and you'll notice our newly created PI key is sitting there ready to go. In just a moment, we're going to point Pi to the right config path so it can pick up those free models we set up earlier. So here we can see Claude has actually exposed an OpenRouter API key directly in the chat, and it's immediately flagging that we should delete it, which is great advice. We're going to copy that export command and run it in our terminal to set the OpenRouter API key environment variable before launching Pi, since that's exactly why Pi couldn't find our config earlier. And if you look at the OpenRouter dashboard on the right, you can confirm this is a real active key. So seriously, rotate or delete any key that ever touches a chat window like this. So you can see on the right side, we've just exported our OpenRouter API key as an environment variable before launching Pi. That's the key step we missed earlier. Now, Pi has spun up successfully, and you can see it's running version 0.88.3 with the Kimi model loaded at the bottom. Notice how it's no longer throwing that no models available warning, which means Pi can now talk to OpenRouter natively without any custom config file. So now we've got Pi up and running with our OpenRouter API key exported. You can see on the right side it launched cleanly and automatically selected Google Gemini 2.5 Flash as our model. On the left, Claude is walking us through the setup process step by step, and we're just confirming to it that we're using Gemini 3. This is the sweet spot where your AI coding agent is now connected to a powerful model through OpenRouter, so you're not locked into any single provider. So now we've got Pi, the coding agent, running in both terminal windows side by side, and you can see on the right it's already connected to Gemini 2.5, flashed through OpenRouter, and responding to our "what can you do" prompt. On the left, Claude is walking us through the setup flow and confirming we're good to go with that model selection. We're about to open our project directory inside Pi so it can start reading our files and we can put it to work on some real code. So here we're switching over to Cursor IDE because it gives us a really nice visual folder structure on the side. You can see the file dialog open where we're navigating to the Fupi Bertomil Paralman Aus project directory. Once we pick our folder, we'll open the Cursor terminal and run those same 2 commands, the export OpenRouter API key line, followed by PI to launch the framework. The key thing here is that PI uses whatever folder you're currently in as its workspace. So making sure you CD into the right project first is what ties everything together. So here we've opened the Pi agent folder directly in Cursor, and you can see on the right we're looking at the models JSON file. This is what tells Pi which AI providers and models it can use. In this case, we've got free options from OpenRouter like Llama 3.3, Gemini 2.0 Flash, and Devstral Small. On the left in the terminal, Pi is walking us through the setup and reminding us that the key thing we actually need is that OpenRouter API key environment variable exported before we run anything. So here we're setting up our models.json config file for the PI framework, which tells our agent which AI providers and models to use. In this case, we're pointing it to OpenRouter's API with 3 free models: Llama 3.3 70B, Gemini 2.0 Flash, and Devstral Small. You can see on the left in the terminal that Claude is walking us through making our OpenRouter shell API key permanent by echoing that export command into our set HRC file. This is really important. Without that source HRC at the end, you'd have to re-export your key every single time you open a new terminal session. So here you can see we've just verified that our OpenRouter API key is properly set as an environment variable. Notice how when we run echo OpenRouter API key, it actually prints out the key value this time, confirming it's been saved successfully to our Azure gccli file. Over on the right in our models.json, you can see exactly why this matters. The Pi framework is referencing that same OpenRouter API key variable directly, so it'll automatically pick it up every time we start a new terminal session. This is the clean, secure way to handle API credentials rather than hard coding them directly into your config files. So now we've successfully set the OpenRouter API key as a permanent environment variable in our HRCE file. You can see in the terminal on the right that when we run echo OpenRouter API key, it's actually printing our key back to us, which means it's live. Over in Cursor's terminal on the left, Claude is walking us through the next step, launching Pi directly from inside Cursor by just typing PI. From there, we'll use the B model command to switch to Gemini 2.5 Flash, which is already configured right here in our models.json file as a free provider through OpenRouter. So, while we're waiting for Pi to launch, we're asking Claude to research what agentic skills are available. You can see it's already fetching the Pi docs at pi.dev docs latest skills. Over on the right in the cursor terminal, the agent is actually investigating its own binary directory, running a find command with type F to figure out what executable files are in agent.q bin, and it's discovered that agent bin fd is a mosh-o 64-bit ARM64 binary. This is a great example of the agent doing self-inspection, essentially understanding its own toolset before it starts working. So while we're waiting for Pi to launch in the terminal on the left, we're having Claude do some background research for us. You can see it's already fetched the Pi skills docs and even pulled in the Anthropics and Bad Logic skill repositories. Over on the right, Claude is analyzing the agent directory structure, breaking down exactly what each file does: the FD binary, the models.json, auth.json. So we have a really clear picture of how Pi is architected before we start building on top of it. So now we're asking Pi its very first question. We've typed summarize what files are in this directory and what they do directly into the Pi terminal. You can see on the right side in Cursor's File Explorer that we're inside the Saki PI agent folder, which contains files like models.json, auth.json, and settings.json, and Pi is already analyzing all of them in real time. This is a great first task because you can immediately verify Pi's answer by cross-referencing it with the actual files visible in your sidebar. So here you can see Pi just autonomously ran a series of bash commands, ls and find, to explore the agent directory, read the files, and summarize everything in plain English, all without us having to prompt each step individually. Notice the status bar at the bottom showing this entire session only cost us that all. Less than a penny, running on Google's Gemini 2.5 model. Now, we're going to take it a step further and point Pi at a real project, the Hermes GTM app, to see how it handles a more complex real-world code base. So now we're pointing Pi at a real project, the Makers Lounge community app, and you can see Pi automatically explored the directory structure, read the files, and gave us a clear summary of everything in plain English. Notice on the right side, it's broken down the agent folder and explained exactly what each file does, like how models.json handles model definitions and sessions, stores interaction history. And the really impressive part? That entire session only cost us, 7, less than a cent, and we've only used 0.3% of our token context window. So now we're pointing Pi at our real Makers Lounge project by running cd users bertomil Makers Lounge followed by pi in the terminal. We're then giving it this first prompt. Summarize this project. What is it? What folders exist? And what are the most important files? And you can see on the right that Pi has already autonomously explored the entire codebase, identifying everything from the Next.js web app to the Supabase migrations and iOS project. This is the power of that core Pi loop in action. It thinks, uses tools, and reports back, and it only costs us fractions of a cent to do it. So what we're seeing here is Pi, an AI coding agent, finishing up its initial reconnaissance of the Makers Lounge project, and it's done a really thorough job mapping out the most critical files across the entire codebase. You can see it's identified everything from the Supabase SQL migrations to the iOS Xcode project, which tells us Pi now has a solid mental model of the full stack before touching a single line of code. Now, it's actually suggesting 3 concrete next tasks for us to try. And those suggested prompts at the bottom are exactly how you want to work with an agentic tool like this, letting it guide you toward high-value actions based on what it just learned. So here we're using Pi, an AI coding agent running inside Cursor, to do something really practical. We've asked it to read the last 3 daily briefings and give us a synthesized summary of what's been going on. You can see on the right that Pi has already analyzed the markdown files, pulled out the key priorities, and is surfacing things like the Claude Code Workshop on April 24th and the Zero to Agent event on April 30th. All without us having to open a single file manually. This is the power of giving your AI agent real context about your project up front, so it can do meaningful work right away. Now you can see Pi has just finished analyzing weeks of daily briefings and surfaced a really clean summary of the key blockers and recurring action items. Things like reconnecting Google Calendar, cleaning up the web app working tree, and finalizing that venue reservation. What we're doing next is pushing Pi from reading to creating. So we're asking it to draft a short action email we can send to ourselves, prioritized by urgency. This is where the framework gets genuinely powerful, because instead of just summarizing what it found, Pi is now using that context to produce something immediately useful. So here we've got Pi running in the terminal on the left, and you can see it's just finished analyzing our project files and surfaced some really actionable insights. Things like stale Notion data, an unclean Git working tree, and an overdue venue decision that's been sitting for over a month. On the right, we've got the Pi docs open to the usage page because we're about to level this up by using Pi session and model options to go from just reading our codebase to actually drafting content for us. Notice that prompt at the bottom of the terminal. We're asking Pi to write us a short action email based on those briefings, which is exactly where Pi starts to become genuinely powerful as a daily workflow tool. Now you can see Pi has automatically fetched the documentation from pa.dev docs latest usage. We didn't have to tell it which page to look at, it figured that out on its own. On the left, it's already surfaced those 7 key recommended actions from our daily briefings, and now we're pushing it further by asking it to draft an actual action email, moving it from just reading our files to doing something useful with them. This is where the real power kicks in. Watch the terminal as it manifests the response in real time. Now, we're on the Pi security docs page, and this section is really important to understand before you start building. Pi has no built-in sandbox. What that means for you is that extensions and tools run with the exact same permissions as the Pi process itself, so real isolation needs to come from your operating system or a virtualization boundary. Keep this in mind as we set up our environment, because we'll want to be intentional about what code we're trusting and running. Now, we're asking Pi to fetch its own documentation page and tell us what features we can actually try. And you can see it pulled down 101 kilobytes of docs and surfaced some really practical commands. On the right, we've got the JSON event stream mode docs open, which shows us how Pi outputs structured events, perfect for integrating it into custom tools or UIs. The ones we're going to focus on first are the easy wins. Things like FLName to reference files directly, export to save your session as HTML, and PIP to run quick one-liners without even opening interactive mode. So here we're inside the Pi framework, a Claude-powered AI assistant running right in our terminal. And you can see it's just finished analyzing our Maker Mondays folder structure, identifying the cover images and HTML landing pages for each event. On the left, we've asked Pi to fetch the docs page and surface the most useful features. And it's come back with a really handy list of commands like a file name for referencing files directly and command for running bash inline. Now, Pi is actually recommending we create an AGENTS.mde file for our project, which will act as a persistent instruction layer so every future session in this folder automatically knows our conventions. That's a game changer for keeping context across sessions. So here we can see we've just exported our Pi session to an HTML file. That command E export saved everything to our local Makers Lounge folder as a nicely formatted, shareable record of the conversation. On the right side, you can see the raw JSON event stream of that session, which shows us all the tool calls, model switches, and token usage under the hood. Now, we're moving on to the next step, which is setting up an AGENTS.md file. This is going to be a game changer because it tells Pi exactly how to behave every time you open a new session in this project folder. So here we're using Pi, the coding agent framework, and we've just run the bar export command to save our entire session as a nicely formatted HTML file. You can see it's been written out to our Makers Lounge folder. Now on the right side, we're opening that exported session file directly in the browser, and Pi is actually reading it back using its read tool so it can analyze what happened and help us categorize all the Maker Monday assets. This is a really powerful workflow. You're essentially giving the AI a memory of everything it did so it can build on top of it in future sessions. Now, we're looking at the Pi extensions documentation, specifically the session lifecycle event. And you can see we've got session before fork right here, which fires whenever a user forks or clones a session via fork or its clone. What's really powerful about this is that you can return on cancel true to block the fork entirely, giving your extension full control over when branching is allowed. So here we can see we're working inside the Pi framework terminal, and we've just exported our session to an HTML file. Pi's gone ahead and saved the full conversation to our local Makers Lounge folder. Now, we're asking Pi to read that exported file so it can verify the session content. And on the right, you can see we've pulled up the Pi extensions documentation to explore how we can start customizing Pi's behavior with TypeScript modules. This is where things get really powerful. Extensions let you register custom tools, add commands, and even build full TUI components that the LLM can call directly. So here we've got Claude running inside the Pi framework terminal, and you can see it's actually reading our exported session file to understand the context of what we worked on. It summarized our style PII config, surfaced those recurring blockers from the daily briefings, all of that. Now on the right, we've pulled up the Pi extensions docs at pi.dev, docs, latest, extensions, because we're about to ask Claude to walk us through a real use case for building a custom extension. This is where things get really powerful. So here we're building a daily briefing generator extension for Pi, and you can see Claude has already fetched the extension's API docs. That 434 kilobyte response gives us everything we need to build this correctly. On the right, we've got the Pi skills documentation open, which shows us that skills are self-contained capability packages that load on demand. Exactly the pattern we want. We typed, yeah, let's build it, and now Pi is fetching the full extension API details before writing a single line of code, which is the right move. You always want to read the docs first before scaffolding something like this. So what you're seeing here is our Pi agent running inside Cursor's integrated terminal. We've just cloned the Makers Lounge repo and restarted Pi in that folder using cd tokoj Makers Lounge and npr. And here's where it gets really cool. The agent is automatically generating today's daily briefing by pulling from previous briefing files as a style reference, and you can see it's surfacing calendar events, Llama registrations, and email highlights all in one shot. This is exactly the kind of agentic workflow we're building. One command, and your entire morning context is assembled for you. So here you can see we've got two environments running side by side. On the left, we have our terminal, where we just successfully cloned the Pi framework and we're about to restart it from the Makers Lounge folder using that cd Makers Lounge and an pi command. On the right, our AI agent in VS Code has already done the heavy lifting, generating today's daily briefing file, daily briefing 2026-07-05.md, using the Gemini 2.5 flash model. Notice how the agent is being transparent with us. It's flagging that the Google Calendar integration still has auth errors, which means tomorrow we'll want to fix that reconnection before the next automated run. Now you can see Pi has just finished generating our daily briefing. It saved it as Daily Briefing 2026-07-05 right inside the Makers Lounge directory. Notice how Pi automatically loaded all our skills at startup, including Brave Search, Transcribe, and YouTube Transcript, which means we're ready to use any of them conversationally. The briefing itself is giving us a really useful project health check, flagging the calendar auth issue, the clean Git state, and even suggesting our next steps, so this extension is already doing real work for us. So here we can see we're exploring the skills available in our Pi framework. I just typed skill in the terminal on the right, and you can see it's listing out all 14 skills that are loaded, including things like skill.findskills, skill impeccable, and skill GUI Pro Max. What's cool is that on the left, Pi is explaining that you don't need to invoke these explicitly. You can just ask in plain English and Pi will auto-load the right skill for you. We're about to test this out using the YouTube transcript skill, which is the easiest one to start with because it requires 0 API key setup. So here we're running pi install git.github.com bad logic pi skills in the terminal, which pulls down the Pi skills package directly from GitHub. You can see it successfully cloned 151 objects and completed the install. This is step 1 of the 4-step process that Claude just laid out for us on the left, and once this finishes, we'll move on to installing the 2 CLI tools, gmcli and gccli.